So let's continue where we left off yesterday. There were two issues. Actually, well, the main topic will be this UHF receiver. I want to debug it and figure out why it cannot switch off again. But actually, I do have a solution for it. I could simply, let me get it. Yep, camera. Here's my solution. The purpose, so the initial goal yesterday when I started this quick hack, which didn't turn out to be a quick hack, was to make this UHF receiver battery operated. You see there's a battery inside here because I wanted to use it during an open air wedding. And now the solution will I will just probably simply take this 12-volt battery, I will connect it to the power input, and because this cannot switch off anymore, I will simply disconnect the battery when I'm done. And this is a legit solution and it works, and there's plenty of energy, so it will get through the day. But while we were doing this, we had another issue. Here, my screwdriver broke. It doesn't charge anymore whenever let me show it to you. Whenever I plug in the charger up here, whenever I plug in the charger, it blinks, and blinking is generally an error instead of something else. So in this case it is an error. So I just open it and we will have a look at what is inside. And as you can see, I've already opened this device once and I've changed the battery once. You see that the batteries have two different colors. One is pink and one is paper-like with a paper cover, simply because the battery in here died. It was at 0 volts. And I changed it with one of my other batteries. So multimeter is ready. You should also see the multimeter output. Let's check if my battery died again. Did I touch correctly? 0 volt is it's a bit weird. Oh, here, minus 3.8 for 3.9 volts. So this battery is fine. Let's check the second battery. 0.3 volts. Okay, this battery is dead. Let me check just to be sure if I did make the contacts. Yes, here. Yet 0.3 volts. Okay, this battery is dead. And you've seen it in a stream. I don't remember in which of my live stream I fixed it, but I put this new battery because it died. Now this one died. I have no idea why. Normally you should have protection on the batteries so they don't discharge too much. They don't discharge between 2.5 volt or 3 volt. It depends. I have no idea why this thing doesn't protect it, or maybe the battery is really dead. But yeah, let's change it and let's put a new battery. And let me get my batteries up. And this time I will always charge it. Normally I don't charge it all the time because it's not a good idea to have the batteries fully charged. They degrade fast, but in this case they break. Although this screwdriver is really old. Oh, really old. It's not that old. Something like 5 years old. So let's put another of these cells inside and let's change it. Let's switch on the soldering iron. Up. Let's wet the sponge on the soldering iron to remove the solder. And let's go to it. So we have a battery here. Let's test the battery first before even starting. Does this exist? It's probably not charged. For the one, it is charged. For the 2 volts. And you shouldn't put two different batteries with a different charge inside, because one will drain faster than the other. But I don't have I do have two same batteries which have been used the same way. These two. I would have to change the tabs, but yeah, we'll do that. So these are two similar batteries, but I could also use this one and have a dissimilar battery. It's not too important because from now on I will keep this thing charged, so there wouldn't be any large issues. But let's do it the proper way and have two similar batteries like these two. So, and it's really simple charging circuit, and apparently no battery protection. No idea why. Here this is the potentiometer, which regulates also with a transistor inside, which regulates how much power goes into the DC motor. Then we have a gear, and then we have the chuck. Nothing really magic here. So how did I solder this? Okay, I soldered it here. Let's get it. Let's get the tab open. Okay, first tab has been removed. You're not seeing. Again, I have to change camera angle. Okay. So first tab is done. And here, how did I do it? Yeah, I soldered also on it. Perfect. So that's plus. Come on, heat up. Okay. You shouldn't heat up the batteries too long, but it's just a short time and it's a huge battery. So, and this should be the second plus, and then we have the second minus. Let's see if I can rip off this tab right here. Because this one is going nowhere. Oh, this is welded correctly. Oh, I broke the cable. Where was it soldered? There should be some remainings because I have the remainings here. I think it's this way. No, that wasn't here. Here. It was soldered on this point. Yeah, I see the remainings. I went too fast. Up. I'm not sure if I will use this tab or I will use another cable. Well, we'll see how it turns out. And same here, and this time I try not to break the tab. Okay. This is now, and this is dead battery. Let's verify again if it's really dead. Yes, -0.3. Everything which is under 1 volt, I don't even charge anymore. I think the batteries are dead. That's one of the problems of lithium polymer battery. If you discharge them too much, they will just die. So here, let's cut these tabs. Because these are two batteries in parallel, we need them in series and not in parallel. And I'm keeping the tabs on the batteries so I don't have to weld mine. This thing is not working anymore. Should have another pair of pliers. This one. Okay. Now I have put them front to back. Let's put them so they're the same way. This won't be long enough. I will need to solder some kind of tab on this side, but on this side it is long enough. So let's heat it up and let's connect it on this side. Let's put some solder in this one first. Where's my solder? Here. This way is cleaner. Either way I have to put a tab. Up. Yeah, let's put solder on it on the tab so I can solder on it afterwards. That works smoothly. Let's do it on the other side too. That works. So minus goes to plus. Okay, this is one side. Let's clean this side so I don't cut myself. And on the other side, I need to put a tab. And normally what you have is nickel strips or nickel plated strips. I should have some because I did some battery welding. Just have a look at one of my QVoodoo videos. I think it's the one with reviving lost memories, something like that. These are the strips which you tap on the batteries. And I have some remaining. Up, up. But they're hard to cut. Actually they're easier to cut with just a pair of scissors, I think, instead of my pliers. Ah, done is done. Let's try with a pair of scissors. Hup. Yeah. Use scissors. Now let's solder this. Let's have something to hold it together. Plus. No. Wait. Yeah, no, don't. Don't solder it. Yeah, I would create a short if I would solder this tab. This side goes to here. I don't know what I was thinking. Maybe too early in the morning. Now I need to solder these tabs on it. It's rattling around a bit, but we will add some pads. So this is minus. Let's put some, there is some solder on it on the first one. There's no solder on the second one. Now there is. So let's put solder on this side too. Oh, that went smooth. minus. Let's wait until it cools. This is done. Where is the small wire? Is it long enough? Do I still want to use it? Yeah, let's use it. I don't want to prepare a new wire. So this was here. So it does tap in the center. So because it taps in the center, I should measure. Maybe it's just for balancing, but not for protection. That's totally possible. Let's solder the plus. Plus. Here the tab, we can solder on top of it. Let's put some solder on the tab. Soldering on nickel is really easy. I don't see if it flows on it or not. Should probably, yeah, just have this single. Oh, this is a bit harder. It's because of the lead. Up. Now I should be able to solder on it. And this is done. So before we close it, let's test it. It turns. Does it charge? And the LED is on, meaning it charges. This LED is on, so it is charging. So this is fixed again. I know this product by heart now. So let's put some pads. I should have some padding tape to pad. I need to find it here. This is generally to isolate doors or something like that, but I will just use it to pad the sides. 1, 2. Up. Pad 1. Oh, this should be cut in 2. Pad. Let's try to put everything back together. Yes, the pad is doing the job. Up. Up. Does it still work? Yes, it still works. So let's close it. Here are the screws. I hope it is charging. We will test it. I will let it charge and then I will test if both cells Now let's let it charge. Normally the charging should be fine. So this battery in the battery box, we don't need anymore. Pliers, we don't need. Try to keep things clean. And you've seen that yesterday my bench was a mess. Now it is clean again. It won't hold for long, I'm sure. It will soon be a mess again. This cell is also okay, so let's put it in the battery box. Pliers. So let's get a screwdriver and screw the top on. Up. Does it close? Yes, yes, yes. Yes, it closes. For those who don't know, this is an IKEA screwdriver. And it does the job. Just for drilling, it's not good. But for a screwdriver, it's inexpensive. It holds well in the hand. No, I'm happy with it. Hop, hop, hop. It's probably also time. So it's not completely dead. I think it's completely dead, or if the battery now don't charge, then it's a sign that, or if it kills again one of my batteries, it's a sign that it is kind of broken and shouldn't be used anymore. So I will get a semi-professional screwdriver instead of this hobbyist thing, which is plenty enough actually. But it will just be the opportunity. Just start cheap, get your hands on it. If you like it, you can still buy more expensive. Okay. It still works one way, the other way, and let's put it to charge somewhere else so it's not in the way. Hop, hop. And this should charge it. Yes, LED is on. Charging works. So, first task accomplished. Let's go to the main task actually. Really, the UHF receiver. So the issue with the UHF receiver, quick summary. I wanted to add battery to operate it with batteries for outdoor. This is what you see here. But I've desoldered it because, well, there's another issue yet. Let me connect the power. You don't see the power. I have to change. I will use. But you can still see the issue. So let me plug the power in, and if I switch, the power should be on. Okay. Okay. $13 the power. Is there no 13 volts on this power output? My power supply is on. This I don't need anymore. Let's switch off the soldering iron for now. I don't know when I will use it. 13 volts. You see it also. Yes, you can also see it on the bench thingy. Ah, I know why. Because this header wasn't connected. So let me connect this header. I think we will have to reverse the board, and we'll probably do that. So if I connect this header, if I connect now the voltage input, you see from the blue light it switches on, and when press on the button power off, it switches off the main CPU, but it doesn't switch off the LCD, and it still draws 300 milliamps. So it can't switch off correctly. So we'll have to find out why this is the case. And for that we need to reverse, probably need to reverse the circuits. So paper, pen, and I think I fried it, probably because I connected directly to 9 volts or something like that. So we have the DC inputs. V plus, minus. This is the battle jack. Then from the input it goes to this diode, which is right here. So let's draw the diode. Then from the diode it goes, it snakes all the way back to this pin. That's, we'll call it pin number 3. No, it's not 3. How is it on this one? I think it's the last one. Yeah, it's not. Let's call it pin. We will call where the J is at the top. The cell screen is at the top. I'll call it pin 1. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. It's on pin number 5. It goes to 5. So 1, 2, 3, 4, 5, 6, 7. 5 is DC in. Number 2, we see it because of the terminals. This is ground. And it also goes, the power also trace also goes here, but this is just to act as a pull-up. It also goes here, but we see we have a 100k resistor, so this is just to act as a pull-up for this transistor. I'm not sure if this transistor is really important for now. For now, we can't switch on and off the power. But the power comes in here, then it goes to this board. And what the power is used here, we can see the trace from, where is he? This one. This is the voltage regulator. We see the trace coming out of pin number 7. So pin 7 is for the L7809, which is this one. This is the power supply for this whole board, and it does work. There is power going into it's the issue that can switch off. Let me test again if it really works, just to be sure, because we didn't test the audio output, but now I just measure the voltage on here. So this is input. We have 12 volts. That's because we have 13 going in. Then we have a diode, and on the output we should have 9 volts. If we have 9 volts, then our voltage regulator works. So this board is powered, so there's no issue. The issue is switching on and off the power. Yeah, so we have to have a look at this board. We see also pin 2 is ground. Here they didn't add any thermal. Maybe it's another designer, because on this one they have a thermal. You see this small lines going from the pin to relieve a bit from the temperature. Here they don't. Does the input go directly? This is the voltage regulator. This one is the voltage regulator for this whole board. This is a 5-volt voltage regulator. Let's measure if it goes directly here. Go into continuity mode. Continuity. So we know that pin, so this is pin 2. Yes, this is pin 2. The DC in is on this pin. Let's try to see if it goes to the input. No. Pin 1. This pin 1 goes to the input of this voltage regulator. That's weird. well, this pin 1, yeah, there's also pin 1 on this side. So this will be pin 1, not where J is. Is it correct? We said that this is pin 1, yeah. So pin 1 goes to the L7805. I would love to have this board outside, but I can't because I can't remove the antennas without desoldering the tabs. And I don't want to desolder the tabs. So something else is switching the power. What is this? This is a huge transistor, and it might be the one switching the power. Let's test if when I connect, so this is connected, if the 5 volts, what goes into pin 1? Which kind of voltage goes into pin 1? Where is... Wait, I don't need USB. You're in the way. I need this one. Okay, it is on. Now we'll have ground connected permanently to one of the ground pads. The tab is ground up. Now I can measure just with one hand. So here we have 12 volts, yeah, almost 13 volts. This is the input of the DC. Then it goes onto pin 1. Pin 1 is 9 volts. Is pin 1 coming out? Is pin 1? Let's test here. What comes inside here? 9 volts. Well, 8.9 volts, so almost 9 volts. So it does actually use this voltage regulator for the 9 volts and uses the 9 volts to again regulate it to 5 volt. This is what I thought in the beginning, and it actually makes sense to do it this way, because you are from 12 volts, from 13 volt to 9 volts, you're already dissipating a lot of heat, and this heat is dissipated by this board, which has a huge ground plane. Here this is just floating, so you don't want to have whole day dissipating here, and probably this uses less current. This is why they don't have to close it. So this is, and here on the output we have 5 volts. That works correctly. So let's test if really the pin 1 is the output of this voltage regulator. Switch off this. Let me put it on the other power supply so you can see what's happening. Let's limit to 1 amp or something like that. 1, 2, and then you can see on the dashboard whenever I switch on and off and how much power it drains, or how much current it drains. The power you'll have to calculate by yourself. Let's use the other multimeter so I don't have to switch all the time, and the other multimeter will just be in continuity mode all the time. So continuity, beep beep, that makes beep. That's a good sign. Now, is the output the pin 1? This is the input of the voltage regulator, this of the 9 volt voltage regulator, this is the output. Yes, it is directly connected. So, that's in, and this is L7 plus L7809 out. So who regulates, who switches on and off the power on this pin 13? Someone is giving the power to this board, and it may be that MOSFET, might be this MOSFET right here. You don't see anything. The MOSFET, which is under here. Let's test it. I just need to probe. This is the voltage input, and let's touch it with... You can only use the continuity test when there's no power going in. And let's test it on these pins. The input is pin 5. This one. Is it? Yes. So is pin 5 going to one of these pins? Yeah. To the center tab of this. Oh. Okay. Okay. I think we have the culprit. You see? Here it makes contact. Here it makes contact. It means that the transistor here is dead. Because if this is a transistor, it could be something else. It looks like a transistor. But you shouldn't have two sides of the transistor completely connected. And it both says that this is at 1 ohm. Is this marked Q? Q. This is marked Q in the reference designator. It means that this is a transistor. So let's switch on the desoldering station. Let's desolder this transistor, and you see that this is a two-part transistor. Yeah. The two pins should not be connected together. This is also a PMOS because it's not connected to ground, and it makes sense because you are high side switching. There's also a test point, and there's a marking which is quite weird. This is just to figure out the model. But there is on this transistor, this is the main transistor to switch the thing. On this main transistor there's also a tiny transistor. I think it's also a transistor, it looks like it, and this is probably to gate the big one. I don't expect this one to be dead. We can check afterwards, but I expect this one to be dead. So let's get the reference also. It's that the B772. I think it's a PMOS transistor. We will check. B772. 7762. I already forgot. B77. No, just B772. Yeah, Boeing 772. Data sheet. B772. Oh, it's a PNP. PNP, yeah, it's like a PMOS. It can be used like a PMOS transistor. I do have PNP, so here, that's the one. This is the SOT version. The SOT version, so on a board, but I think it's they are in plenty of other packages and formats. Let me check, for example, yeah, this one. Click to view. I want to download it. Let me do. I hate sites like all data sheets and things like that, because I find no way to download the thing directly. Let me download the ST-B710. I don't know if it's ST, but apparently ST does one of them. So let's switch this back here, and let's have this one here, and it looks like the right package. TO1126, that's the package. High currents, this is a PNP, yeah, PNP transistor. Same principle as PMOS, you put it on the high side. So let's desolder it and let's test it. Up, my desoldering gun is warm. And there is no power going in. I will still unconnect the power supply because for now we don't want to put any risk. This is the board And now let's desolder it. Yeah. I have to tighten up the screw here. It gets loose really fast. I don't know why, because maybe heat cold makes that it resets all the time. Okay, desoldering gun is there. And now the part should fly off. It is a bit warm. That's the part. How much beta or current or what is the spec? Current 3 volts. That's the collector. I forgot how it. Yes, collector current. 3 amps. And peak something like 6 amps. So if we want to change it, we have to use also a. We could use a MOS. I don't know. Let's try to find a transistor. Let's test if this works. So for that, we will just use a transistor tester. Something like this. I don't know. This is a multi-part tester. It's really amazing. With just here, it's just an 80 mega 328p. This microcontroller, they put so much intelligence in it that it can figure out a plenty of different parts. And I'm sure this will be identified as either dead or we don't know, but it's probably not identified as NPN. See, 2 diodes. If we put an NPN transistor, I should have some of them. Oh, I do have transistor mix LED MOSFET mix. It's not only MOSFET. Here we have NPN transistor. Oh, and this is an NPN transistor. But we need a PNP transistor. I also have PNP transistors. If we put a PNP transistor, it should identify it correctly. That's an NMOS. Okay. So at least identifies the NMOS correctly. Let's try to see if it identifies this NPN transistor correctly. PNP. Sorry, PNP. I always confuse NPN and PNP. PNP is generally for the high side. NPN is for the low side. And here we have the parameters. HFE is the gain. 300. Let's note it down. 667 HFE, that's the gain, and then this is the minimum voltage. UF is 331 millivolts. Let's test if this works, and let's have a look at this data sheet. If the pinout is the same, I will just use this part as replacement and figure out if it works. The pinout, it's almost the same. It's not, the package is different, but the pinout is almost the same. And this is, yeah, NPN. I always PNP. I also have other PNPs. Let's switch off this thing because this is really loud. The digital soldering gun. And let's hope that this was the only issue there was on this board. So let's have a look at the second data sheet. This is TST 06A60. TST 06A60. Data sheets. Yes, give me a data sheet. Okay, that's not the data sheets for the part I want. PNP. PNP. I don't know what this logo is from. National. Let's put the last part away. TST06A. Let's try to find if there are data sheets for that. I want to check it's probably also capable of carrying 3 amps, but I want to check on the datasheet if this is the case. I don't find any datasheet for this part. So we don't need this anymore, we want this. And because this is a PNP transistor, we don't really care about voltage threshold and so on. This is more important for MOSFETs, not for BJTs. But no one knows about this transistor. They all have the connector, but no one knows about this transistor. Would be nice to have a small data sheet for it. No. Let's remove the TST and let's have 06A60. Maybe some... someone is ringing. I'll be back in a minute. I have to pick up a package. And I'm back. Package is from China. So we won't find a data sheet. I think this PNP transistor is plenty enough. I want to see if the pinout matches. That's probably the most important part. So it is BEC. On this one, yeah, maximum voltage. I think we are plenty fine. No, the pinout doesn't match. This is BCE. And we have BEC, so we need to find another one. Luckily I have some other ones. These are scrap parts. Things I've moved. BCE, that's the right one. You see the power is a bit less, but it's still fine. These are all the same. Yeah, these are all the same. These are BD240B. I think datasheet for that is probably available, and it is from Philips. I've never seen this logo. Did I? Philippines. Who is this logo? If you don't know, I do have a website called iclogos.qvoodoo. iclogos.qvoodoo.info. Let me switch the screens. This thing. I already also make a video episode about that, and I put logos of parts I find, and these are SVG logos, so really good quality logos, and then the link. So in this helps me identifying who is the manufacturer of this part, and this way I can find then the parts a bit more easily. But I think I don't have the one from this one, so let me switch this back. Now this is a BD240B. BD240B on semiconductors does it, but plenty of other people do it also. Let's give a data sheet. That's the data sheet. This is the transistor, and we see we have BCE, the same as this one, BCE. Now let's check if the other things match. Voltage 80 volts maximum, that's fine. We have only here emitter base voltage, that's the maximum. Emitter base voltage -5, it's the same thing. The current, how much is it capable of carrying? 2 amps. This is 3 amps, but we've measured it that it is we are only using 0.3 amps, so this part is fine. So we'll put this in place. It's a lot larger. The pinout probably matches. Switch on soldering iron. This is the part. This is the replacement we will use, and we will check if it works. I don't remember how it was soldered on. I think it was this way. Which one was pin 1? The tab was on the back. Yes, it was this way. It was soldered this way. And we have plenty of headspace. That's not an issue. Yes, because the writing was on the front, so this is the right way to do it. Up. Let's solder it. I will not put it on for too long because maybe something else might be broken. And since something else might be broken, which caused this transistor to be break, I don't want it to be on for too long because it might break this transistor. Also, up. This is on. We can cut the leads afterwards. For now, I just want to test. Let's put power on. Switch on power. It didn't go on. That's good already. So here, the device didn't go on. You don't see the blue light, which is a good thing because per default it shouldn't go on. I should press on the on switch, which I do now, but it still doesn't go on. This part should be fine though. Same footprint. Wrong power supply. This power supply. 3 milliamps. This is the standby current. This is already a good sign. The 3 milliamps you are seeing is you're not seeing because the datasheet takes all the space. And this is broken. Yeah, the 3 milliamps you are seeing was the standard by current of this device, and you see it's not on because there's no blue light. If I switch on, I can switch on. Okay. Something else might be broken. At least the standby current is correct. Yeah, but I can switch on. If I press on the button, it just doesn't switch on. Which is worse than before, because switching on is probably the most important part. Is it the right side? No, this should be pin 1. This should be correct. We can check. So this is a transistor. The idea of this transistor is to let current go from what is a pinout. I can just short the pinout to see if it works. The pinout is 1 is base. So if I short pin 2 and 3, we should have some current going through, and this should be on. So this is pin 1. If I short pin 2 and 3, we should switch on. It doesn't switch on. They are shorted. No, it doesn't switch on. If I short these two, okay. If I short these two, it does switch on. Ooh. This is 1 and 2. Let me test them. This MOSFET again. We have B, C, E. Okay. Have a look at that. Here on this data sheet, this is the front, and then it's not 1, 2, 3 from left to right, it is 1, 2, 3 from right to left. Compared to this one, I've never seen. Who does that? 1, 2, 3 from left to right. Compared to this one, where it is 1, 2, 3 from left to right when you see the front. Who does that? Seriously. There might be standard for this package, I don't know. So let's just switch around, and this is why when I connect, so let's desolder it, switch it around, test it again. So we have to wait for the heating gun to heat up, for the desoldering gun to heat up. Which takes a bit of time. Yeah, I'm also waiting 300 degrees to 250 degrees, and I go up to 400. 400 is a lot. You could scorch pads with that, but at least if you do it quickly, you should be fine. We are at 300. 300 should be fine for the first one. 1, 2, 3. Let's leave it on because I'm sure there will be other issues. Now let's turn it around because the pinout in the data sheet is shown the other way around. I should have broken. I don't think I did break the transistor because there's not a lot of current which passed through it. Up. Now it's the other way around. Let's solder it. Up. That's soldered. Now let's test it. 3 milliamps when off. I can switch it on. It works. You see the faint blue light. And I can switch it off. So that was the fix. Nice. And this transistor is plenty enough. So let's cut the leads. Let's switch off the power supply in case I just break anything. Where is my cutter? Here. So this is fixed. And I probably, when I connected the 9 volts directly, don't lose the thing directly to the input, it probably broke this thing. So let's not do that because it switches off not the 9 volts but the 11 volts. So let's input 11 volts, and I think this thing should input in there 11 volts. So let's connect everything. So now purpose again, reconnect this thing which powers the battery, and the battery should wait, wrong cable. This is the right cable, but I don't want the cables to be entangled in a way I don't want. Now let's do it for now this way. If this works, so this is the ground from here. They're all the same ground, so they should be fine. Although no, it's not the same ground because this ground can be switched off by the protection. So here we have the battery connected to it. Let's test if the battery works by simply plugging in the charger, the USB to charge it. Up. Okay. The battery works. The battery charging works. Let's measure the voltage on the battery. I'm surprised it doesn't charge up to 4.1 volts, but it's 4.2 volts, but it's 4.1 volts. So the battery is kind of charged. That works. What is the output from this MOSFET if I switch it on? Yeah, ground is not connected. I can connect it using this clip. Ground. We are in voltage. This is off. This is on, I think. 5 volts output. 6 volts. Okay, no. The contact is wrong. 11 volts. That's good. 11 volts. This is what we want. Ideally, we would have 13 volts. Let's try without the charger. Ideally we would have 13 volts, but it just chews too much power, and 11 volts should be fine. Good. We will test it. I can still switch it on. Okay, this works. So now if I connect this pin to the diode here, we should be fine. Let's have up. This is the output of this voltage regulator. This is the output of the diode here, this way. And now if it is switched on still, isn't it? No, it's not. Now I switch it on. Okay, 11 volt come in. Let's try to switch this on. Yes, it does switch on. I want to test if it receives data and if it outputs something. So let's switch this regulator off. This regulator, sorry. Let's switch my desoldering gun off. Let's put this inside. What I hated this desoldering gun is that the solder really sticks really fast inside here. This is why I put it in 400 degrees, so it doesn't get stuck in here when it draws and the flow just cools it. This is a huge disadvantage, and this is also why I put this in the end. This way I know, okay, it is free. And now I can put it in here. So let me get the microphone up. So let me get this microphone back here. So my headset microphone. So this is the hand microphone. Let's put the antennas on, else it won't receive very well. It should receive though, because we are really close to it. Probably lots of distortion. That's the inputs. That's the second antenna. I want to test both antennas, and it's for the two, so these are two distinct. It's not for diversity, it's simply because it has two receivers. Then we have my Bluetooth speaker, which has
device is ready to pair.
Inputs
Connected successfully.
Hub, which has an aux input. Out input connected. So let's switch this thing on. This is on. Now let's switch this on. It says that it recognizes. Oop, I did make a short somewhere. I shouldn't. Maybe when I moved I made a short. Oh no, it does switch off. Who switches off now? Who is the culprit? Is it because it's showing too much power? So, or maybe because let's connect the multimeter to the output of the battery. Not of the battery, of this thing. Okay. The battery probably. Here we don't have any output. Do we have... The battery is fine. Do we have inputs on this side? Okay, the battery... We don't have voltage inputs on the transformer. Let's connect now to the battery. I can't directly because I don't have ground. Ground is connected here, and but ground is not connected to this thing. So let's test the voltage of the battery with another multimeter, because now the ground of the battery is disconnected. This is ground of the battery, this is plus of the battery, and my other multimeter will read the battery voltage. Maybe there's just too much current going through and the battery protection switches off. I don't remember. So the voltage, 4 volts. Switch off, switch on, switch on, 3.7. No, 3.7 volts. The battery went down to 3.7 volts, which is already not a good sign, but it shouldn't be a problem. 3.7 volts. It should... yeah, then it goes back to 4 volts. Let's measure how much current goes through. So let's disconnect this side. This way we can measure the current going through. And I don't remember, so this battery protection, I don't remember how much current it lets through. I think you can change it using one of these resistors. We'll probably have to. But for now, let's try to measure this. So the voltage, this is minus. Minus should be connected to this minus on this tab. This one. This is the minus up. Okay. Now we have the minus of the multimeter connected to the battery. We go to amp mode and we have the plus of the multimeter connected to this cable. This way we can measure how much current goes through, and probably it switches off because it chews too much current. So let's go into current mode. If I switch on, switch off, this was switch on. This is the standby current. This is, you probably also see it. You don't see a lot because of the data sheets. Now you see it. We have around 25 milliamps of standby current. That's okay. If I switch on, we have 700 milliamp. But it doesn't switch off again. And it works pretty nicely, I think so. Let's test the microphone. Microphone on. The thing shows that it is on, and if I test it, yes, the microphone on works. This is the first one. Let's test the second microphone, which is this one here. Microphone on. It received the data and it says that it receives, and it works. So it chews a lot of power. It chews almost 1 amp. This is this pack is 2000 milliamps, so it should have something around 2 hours without charging. With charging, it's probably more. I will bring the battery so I can still plug the 12 volts. I will also have power banks charging this thing. So if it's not used, then it charges it. And I think 2 hours is plenty of runtime for this device. If you want more than 2 hours, it's more than 2 hours. 700, 800 milliamps. It's something like 3 hours, a bit more than over 3 hours. But this circuit works. And if I switch off, it switches off. There's still a huge current used. 500 milliamps used. When switched off, something is not switched off. Switch on. Yeah, if you switch off, you really have to disconnect the battery. Switch off. That's not normal. If I disconnect the battery, if I reconnect it, then it have 25 milliamp. So yes, you should switch off the battery on the inside. On the outside. I don't know why it has the standby current. When you switch off, why it has the standby current of 500 milliamps. Switch off on the back. Do I want to figure it out? It shouldn't. Why could this be? Is this using power, or is this thing burning the energy? So we can, if I disconnect here, yes. No, it wasn't that. If I reconnect, 500 milliamps. Let's measure if the current going through here. What is the current going through this device? So let's use a second multimeter. Let's switch the battery on. No, that's off. let's switch the battery on. Ah, I have to connect it this way. This is on. Okay. It's using 200, it's using 200 milliamps on the 11 volt line. If I switch off, it goes down to 25 milliamps. So this thing is not switching off correctly. I think it needs a I just make a spark. This, yeah, just plus minus. Let's switch off and on again. It should still work. Probably saw the spark. Yeah, you probably saw it. Is everything dead? Battery should be fine. Ah, maybe the battery protection kicked in. So let's reset the battery protection. Battery protection reset. And now if I connect here, what is on? I forgot. Okay, it works again. Yeah, 200 milliamps. If I switch off, then it goes down to 25 milliamps, but the battery, this module here, still shows 500 milliamps. And I have no idea why. Maybe it needs a minimum load to switch off correctly. I don't know. But the issue is really this module here. This is the only thing which chews the power. As soon as I disconnect, it stopped chewing power. If I reconnect, it chews the 25 milliamps. Okay. I don't know why. Problem is that it draws more than I can charge, so why is this module showing power? Is this module showing power when I disconnect my way? So let's connect it again. Battery on. Okay, this was battery off. Battery on. Okay, this is on. If I now disconnect this way, it switches off. Well, not completely. It still chews 16 milliamps. This is just for this to operate. 16 milliamps seems to be the quiescent current for this module. It's still a lot less than the 500, and I think so. Let's connect back. Now it chews more. Switch on. Switch on. Switch off. 500. I have no idea why. I don't know why. Why does this module, whenever I draw 25 milliamps, it still draws 500 milliamps? It shouldn't. There's no load, so... and then it just burns it away. Yeah, I just have to remember that when I battery operate it, that when I want to switch off, I need to switch off here. I'll mark it also. Oh. Switches. That's off. That's on. Whenever I switch on, it goes to 500 milliamp to boost, to start it. Yeah. Does it require a minimum load? But there is a minimum load. There is 25 milliamps. And when there's no load, so here there's no load, it goes into power down modus. So why, when there is a bit of load, it just goes crazy? Does it change if I add a capacitor? Because maybe it's at a frequency which makes it go haywire? I don't know. I don't know well enough how these things work, how the switching power supply works. But let's try it out. We need a capacitor just to test it. I need something which is withstanding 25 volts. This is fine. Let's connect the capacitor and see if when you connect the capacitor, this is a large capacitor, 1000 microfarad, really large, but this should be plus out plus is also here. All these all these crocodile leads everywhere is probably not a very good idea. For now it will be sufficient. So I've added a capacitor. Now I can connect this again directly. What is this? This is the output. And okay, this is the output. Let's connect it here directly. Switch. That's off. Switch on. 700 milliamps. Okay. Switch off. 500. And the capacitor didn't change a thing. So adding more capacitance doesn't change it. So it's not something with a resonating circuit. Probably not something with resonating circuit at the end. There's another reason. And it's not, this doesn't draw. So it's not because the board draws. The board is switched off correctly. Do I want to try with yet another of this module? Maybe this module is... Oh, now it did switch off. When I touched it, it did switch... What? Let's try it. Switch on. Switch off. Maybe we just have to wait. Let's wait a bit. Without touching. No, it doesn't do anything. I've waited long enough. Now what happens if I touch it? Okay, I have to wait really long. Let's try again if... Yep. Let's use the stopwatch. No, mode. What is here? No, that's not. How does this work? No. That's the date. Okay. Stopwatch. Here, just a simple stopwatch. I like to use it for measurements. So switch on. Okay. Switch off. Let's start it. Let's wait 2 or 3 minutes. Here's the stopwatch. Maybe after some time it will just shut down. Without me touching it. Let's wait 2 minutes without me touching it. Let's say 1 minute. I'm just too impatient. Okay, nothing happens after 1 minute. Now if I touch the capacitor, what did I touch? It did go to sleep at some point. So now I'm touching things everywhere again. It doesn't do anything. So this was a coincidence. Now it doesn't go off with time or with me touching. No, still 500 milliamps. Well, I'll be the one operating it, so I will know that I will have to switch off the battery. Yeah, I don't know what caused it to stop. I'll disconnect this capacitor. I'll short the capacitor. Whew. Because I don't want to keep it charged. But yeah, it doesn't go down. I don't know why it doesn't go down. I don't know what to do. I don't think it has anything to do with... now it went down after 3 minutes. So let's try again. Switch, sorry. Now it doesn't want to go on. Come on, go on. Is the battery dead? Switch off, switch on. Now it doesn't want to come on. There's something wrong with this module. I think this module is dead. Luckily I have other ones. But now it shows 500 milliamps and it doesn't want to go 800 milliamps and it doesn't want to go on. I think this thing is toast. And it's warm. Yep, I think this part is dead. Let's change it. I have enough replacements. So let's disconnect the battery is disconnected. Let's desolder everything. Let's put the microphone away before I break it. Up. I think this thing has also got some damage. And now, damn it. Is dead. So that's the input. Up. Let's get another of these boards. Input minus. This is ground, out minus. That's input minus. And it doesn't want to go in the hole. No, it does. Input minus. Okay, we don't. Let's try. That's solid. Input plus. Does this want to go in? Yes, it does. Okay, now let's not connect anything on the output, and let's try if what this thing does when I switch on. Okay, 25 milliamps, that's the quiescent current. I can live with that. It's a lot, but I can live with it. Now let's test the outputs. So this is minus, output minus, and this must be plus. Let's get the cable out of the way. Plus. Let's switch it on. Switch this thing on. First I have to set the output voltage. I didn't set the output voltage. Let's use this multimeter to measure the voltage. Let's set the output voltage. This is measuring the current. Let's leave it here. There I want to measure the output voltage. 1, 2. What is the 21 volts? Ooh, I did connect 21 volts here. That's not a good idea. It should switch on though, but it's not a good idea. I hope I didn't break anything. I should have tested it before. Let's go down to 11.5. No, it's the other way around. Okay, that should be good. Let's test if this thing works using just a normal power supply. I hope I didn't break it again because I didn't pay attention. Where is the connection? Here. Come on, go in. Switch on 13 volts. Okay, this is not broken. This works. Up. Now let's connect the outputs on here. Normally we should be able to switch our device on. We are not able to switch our device on. Is 11 not enough? It does show 500 milliamps. Let's switch off, on. Why don't you work? What's the output voltage? Up. Voltage. Voltage. 4 volts. Okay, this is why it doesn't start. Because it's only outputting 4 volts. Now it's outputting 11 volts, and I think if I power this, then it goes down to 4 volts. This shouldn't be, maybe because this battery is now getting low. Let's measure the voltage of the battery. 3.9 volts. No, it should be fine. Switch on. 3.2 volts. Yes, the battery is now too low and the thing cannot regulate correctly. Let's put the battery to charge. Let's switch it on and let's try if this works. This is off, isn't it? Yes. Which way is on? Yeah, you shouldn't. While you're charging the battery, you shouldn't use this device. Particularly when it's too low. And the voltage regulator, the battery charger, would have a huge issue managing it. How to do it without that? We will simulate the battery with just this power supply. Where are the leads going to this from this power supply? Here, good. I'll use my second power supply to simulate the battery. That's you have to charge though. So battery out, we'll connect it directly here. And let's set the voltage first before I break anything. .7 volts or 3.9 volts. I think this regulator needs at least 3.5 volts to operate correctly. And now I want to measure the output voltage. 11 volts, and this is showing 23 milliamps. Now if I switch on, it should work. Do I have to disconnect the battery? Let's disconnect the battery. Oh, it was disconnected. The battery was disconnected. So you can provide enough current at the beginning to switch it on. We did try it, it did work. Let's try with 4.2 volts. 4.2 volts. Now it's showing 1 amp. Okay, it's not anymore. Let's switch it. It can't switch on for long. Do I have to switch more than 11.3 volts for it to work correctly? Let's try 12 volts. This connection, well, it's not too good, but it still withstand this low amount of current. So we have 12 volt output. Does it work better? It automatically switches off. This is not able to cope with the 12 volts. This should work fine though. That's the input, that's the output. This is a voltage booster. As soon as I try to switch it on, it can't sustain and it doesn't switch on. And you see the voltage drops. Yeah, I don't see the voltage anymore. Yeah. If I use power, the voltage dropped to 6 volts. Normally, that's normal. Why can't you withstand the voltage? You should be able to provide plenty of power, 3 amps easily. Okay, you're getting warm, but not that warm. Volt output. It's showing 20 milliamps an input. I'm getting fed up with these volt boosters. As soon as I switch on, it goes down to 6 volts. But still, there should be. Let's try to measure the input. At the input, does the voltage drop? Is it because of that? For the 2 volts on the inputs, if I switch on, does it go down? Yeah, 3.6 volts. Connection's not good enough. Yeah. And it needs at least 3.5 volts. Else it goes haywire. And is this cable too long? There's only 1 amp going through. The resistance of this cable should be low enough. But we know that this is because the input is going too low. Damn it. It is getting annoying. Crocodile clips are maybe not the best solution to provide lots of current. I have nothing else currently. Let's cheat. Let's not charge a battery, and let's do as if. And let's put the voltage input on the battery. Which cable is it? Battery minus, this one. Here, battery minus, directly connect to the 4.2 volts. Battery plus, directly connected. The battery is not charging. The battery is not charging because I don't connect to the battery. Let's switch on. It draws 20 milliamps. Let's check the output. 11 volts, and if I switch on, cannot keep on. The wires should be sufficient. Let's connect to. So this is the output. Let's connect to battery in. For the 2 volts, as soon as I switch on, 3.7. But it cannot latch. This is because the output is not good enough. Okay, the cable is too long. Maybe. Maybe my cable is too long. Let's try. I have other crocodile clips which are a lot shorter. So let's disconnect this. Use the crocodile clips. Which one? This is crocodile clips. Short leads, really high currents. That should be fine. A lot shorter leads. Plus, and let's switch to for the 2 volts. And now you can see using the bench power supply what is happening, and crank up to 2 amps. Up, switch on the output for the 2 volts. Now if I switch this on, I have no idea. Okay, it's still using the current limits. Okay. Oh, it draws 3 amps. That's huge. It is on, but it draws 3 amps. Okay, in the beginning, then it goes down. 1 amp. It does work, so it really needs a huge battery with beefy battery in the beginning. But it does work. So I think it really needs a charged battery. Yeah, let's start. I think it works for a couple of half an hour probably, battery operated. If you don't charge, else just provide 12 volt externally. 12 volts should be fine. What's the voltage output? So this is this. What is the voltage output? Let's go down to 11 volts. It is 11 volts. Voltage output is 11 volts. At 11 volts it draws 1 amp when the battery is at 4.2. If we switch the battery lower, it draws more. That's normal. 3.9, it draws 1 amp. But it still works. Let's switch it off. Okay, at least switching on and off works. It doesn't draw 500 milliamps now if I switch it on and off. If the battery is not full, okay. At least it's a good sign. If the battery is not full, it won't be able to switch on. Yeah. Well, we'll do it this way. So see, if it's at 4 volts, it's not able to keep switching on, because it's not able to deliver the current, the starting current. Now it can switch on. You have to press a long time on it. If I follow 2, it works better. Let's do it this way. Yeah. I will use the 12 volt inputs, and surprised how long it will hold. Let's charge the battery. I won't do it now, not in the live streams, but I'll charge the battery, and with the battery completely charged I will measure how long it can resist. For now the battery is not completely charged. If it's less than half an hour, I will add a battery in series, in parallel. I'll use another configuration. In parallel, in series I can't, because this is not a charger for in series. I will have to add it in parallel. I will have to add a battery in parallel if it doesn't work. For now, let's close it. Let's solder the cables. Now let's switch this off. Let's solder the cables and let's use it, and let's test it like this. Afterwards, if it doesn't hold for long, once the battery is completely charged, I know I have to change something. This is getting toasty. This is getting warm. I'll have to put it somewhere. Oh, I wanted to put it on here. At least there is a heatsink, but I'm afraid, yeah, I will have to put a heatsink pad. I don't want this to short on here, but using heatsink pads I think is good enough. Let's clip these pins, so it is flat, and the heatsink works best. Okay, so let's connect the wires, and I think, yeah, this died probably during my experimentations. It's okay. These are consumables. Up. So this is the output. Let's solder the wires on the outputs. Out minus. And probably too thick for out plus. So let's up. Yeah, too thick for out plus. Let's use this side. This is thinner. Out plus. Let's start with a heat gun, with a soldering here, hot glue gun. I have to put my microphone. Now I'm back. Let the heat gun heat, and we will finish the soldering meanwhile. Put the components back together. Up. This is minus. Wheeze, leads go away. This is the dead one. It goes into e-waste bin. And yes, I do put it in the correct bin. Okay. So let's screw the boards back into place. These are the screws. Oh, heat gun is heating. These are the screws for this one. One. One, two. Let's now line up. Then the screws for the back one. One. Oh, I shouldn't have tightened up now. I can't move the board correctly. Into place. Yep. Untighten it. Tighten this one. Tighten this one. Now I need to solder the minus. No, that will be in the end. This is done. This is done. Oh, let's leave it open, meaning I know that there's nothing inside. The minus from here will be soldered directly onto this huge minus there. Right. Let's use our tweezers because I don't want to get burned. Yeah, all the minus are connected together, so I think that's fine. it takes time because this copper plane is so this ground plane is so huge. I can't heat it up. Okay. Oh no, that's a bad connection. Is there not a ground point which I could use, which doesn't sink too much heat? Okay, ground is connected and there is no short. This is the ground of the other one. Now the plus again should be connected on this diode output. That's the plus. Tweezers. Okay, plus has a good connection, minus has a good connection. Let's put the cable back in. This must go on the side. Else the cable has no chance going into it. Okay, cable is in. Let's try with the voltage output. So this is minus, this is plus, and if this works, we can start closing things. On, battery on, it draws 25 milliamps. If I switch on for long enough, it stays on. It draws 2.5 amps at the beginning, but it should go lower once it's regulated well enough. 2.6. At least we know that this board allows 3 amps to go through. Why don't you go down? Three amps, it only goes up. Go down. Okay, now it goes down. Now it's 1 amp. It chews a lot in the beginning. And I can switch it off. Okay, it works. Let's disconnect the battery. Up. Now let's put everything together. I have some heat sink pads. Up. This is some heatsink tape, and this is what I will use to put this on here, and I hope it will heatsink a bit of it and it will stabilize it. Okay, we can put 3 of them. Scissors. Is it long enough? Yes. 1, 2, and 3. Oh yes, this is getting toasty. No wonder the small one didn't work at all. One, okay, just two of them are going on it. 1 and 2. I'll put a third one in the middle because it is a bit below. 1, 2. Let's put this one here in the middle. 3. Yes, let's put it this way, in the middle of the can. Let's hope that the can will spread the heat away. Let's try it again to see if there's no shorts. Minus, plus. This should, yes, this should hold well enough. I will add some glue on the side just to hold it a tiny bit, but I'm afraid that the glue will melt. This is on. This is on. There's something wrong. It should draw a tiny bit of current. It doesn't draw anything. If I switch off, no. Okay, now this is on. No, it's off. Is there a short between some of the pins? It should draw a tiny bit of current. This is the right minus. Minus. Okay, let me test if there's a short. Here. This. Where are my multimeter leads? I won't use this one. I will use my other multimeter. Tac. What is the resistance between plus and minus here? Okay, there's a short between them. Oh no, there's no short. It's because there's a voltage input. So I can't measure the ohms. There's a short. Okay. I must add more pads on this side. Does this still work now? Yes, now it works. There was a short on there. So let's add more isolation. On this side and on the other side. Up. Do I want to test it again with the multimeter? Nah, sure, it will be fine. Oh, it's not the clean way to do it. Let's do it cleanly. Up. Oh, let's switch off the power supply. And this is because I put soldering on this side. If I would have put it on the other side, it would be better. Let's try to make them flat. Let's try to make it flat. Up. Okay, now 2 long strips, 3 because we want to add one in the middle. One. Two. Okay. Come on. One. Two, and so it doesn't press too much on this solder thing. Let's add a strip in the middle. We could even, if it's long enough, we could add it between both shielded cans, so it shares the load between the two cans better. Up. I'll put it just on one side. Somewhere in the middle. So let's measure the resistance. Resistance is high. Resistance is high. Let's test it. For the 2 volts, switch on, 25 milliamps, that's the standby current, looks good. I can switch it on. I have to stay for a long time until it latches. Now it's latched. This works. Off. And 25 milliamps and quiescent current. That's good. So let's add some glue to it and to the switch. And here is the fan. We can power the fan again using this thing. Switch on. Yes, fan works. Let's add some glue, just so it doesn't move too much. One side. The other side. Up. Let's wait until it cools down. Let's make one after the other. Hold on, no, I'm too impatient. Glue takes too long to settle. Let's okay, I have to wait. Okay, glue here. I think I need a new glue stick, since I have to wait a tiny bit for the glue to settle in. I'll get a glue stick. Can I bring you with me? No, I need to put the microphone away. Okay. Glue stick, new glue stick, and it's actually another brand. So maybe it even works better. So this is cooled, the other one is cool enough for me to continue working on it. I need to solder the minus now of the battery before I install it. Battery is disconnected. This is the minus. Up. And I did put it below, above the cable. I should put it below the cable. Up. Okay. Let's glue the battery in. It doesn't need a lot of glue though. It holds pretty well. That's holding good enough. That's cooling. A huge metal plate is sinking the energy well enough. This is not moving. But I'm still adding more glue on the sides because this is the battery. It has a lot of energy and I don't want it to get loose. Up. Glue. Last piece. Pièce de résistance. It's not. Pièce de résistance is the main piece. Plenty of cables on the way. Let's connect it to a unconnected USB cable. Let's get one here so we can hold it in place. Yeah, this cable. Okay. So this way. Can I put some doesn't hold well. Would be nice to have some kind of contraption to hold it while I tack it into place. Okay, I'll have to do it by hand. Up. Okay, now I have to hold it until it cools down. There's nothing else I can do. I can still have a tiny bit of margin to. Okay. Try to help with the cooling. And it's the wrong way around. this way works better. The first part is getting translucent. That's a good start. Yes, now it's holding. Let's wait until it is getting a bit more translucent. And looks okay. Now we can put the rest of the glue so it holds well together. Plenty of glue, a bit everywhere. I want that it resists the insertion force. Switch off the output here. Not sure why it is still on. Okay, translucent enough. Let's get rid of the strings of glue to have it look professional, because this is what you expect from me, professional material, right? Up. So let's try to connect the USB, see if it charges. Yes, it does charge. I see the red LED on the bottom. And let's wait until it turns blue, and then we can test how long it holds. But let's try. No, I can't try if it starts, because there's not enough enough juice in these batteries. It has to charge. It has to fully charge first. So yeah, we've tested. It works. It should work fine. And I will still bring the 12-volt adapter and connect the 12-volt battery. This will just be the rescue plan if 12-volt is going off. Or I can choose. I have to write that this is the battery. This is battery charge. This is battery on. Battery power. But I'll do that once I've tested that it works correctly. And with that, the project is done. We have a battery operated UHF receiver. I'm happy if it holds 1 hour. That's my goal. But for that, with that, this project is complete and this live stream is complete. It took a bit longer than expected, but yeah, it works. So for you, enjoy the rest of the day. And I'm going to lunch. Bye bye.